Why is IOC/D not common in Python? In Java, IOC/D is a very common practice which is extensively used in web applications, nearly all available frameworks in Java EE. On the other hand, there are also lots of big Python web applications, but beside of Zope, which I've heard should be really horrible to code, IOC doesn't seem to be very common in the Python world. Please name some examples if you think that I'm wrong. There are of course several clones of popular Java IOC frameworks available for Python, Spring Python for example. But none of them seems to get used practically. At least, I've never stumbled upon a Django or SQL Alchemy Plus based web application which uses something like that. In my opinion, IOC has reasonable advantages and would make it easy to replace the Django default user model for example, but extensive usage of interface classes and IOC in Python looks a bit odd and not Pythonic. But maybe someone has a better explanation why IOC isn't widely used in Python.
Part of it is the way the module system works in Python. You can get a sort of singleton for free just by importing it from a module. Define an actual instance of an object in a module, and then any client code can import it and actually get a working, fully constructed/populated object. This is in contrast to Java, where you don't import actual instances of objects. This means you are always having to instantiate them yourself, or use some sort of IOC/D style approach. You can mitigate the hassle of having to instantiate everything yourself by having static factory methods or actual factory classes, but then you still incur the resource overhead of actually creating new ones each time.
I don't actually think that D/IOC are that uncommon in Python. What is uncommon, however, are D/IOC frameworks/containers. Think about it, what does a D container do? It allows you to wire together independent components into a complete application. At runtime, we have names for wiring together and at runtime. Scripting. Dynamic. So, a D container is nothing but an interpreter for a dynamic scripting language. Actually, let me rephrase that. A typical Java/.NET D container is nothing but a crappy interpreter for a really bad dynamic scripting language with but ugly, sometimes XML-based, syntax. When you program in Python, why would you want to use an ugly, bad scripting language when you have a beautiful, brilliant scripting language at your disposal? Actually, that's a more general question. When you program in pretty much any language, why would you want to use an ugly, bad scripting language when you have Jython and IronPython at your disposal? So, to recap, the practice of D/IOC is just as important in Python as it is in Java, for exactly the same reasons. The implementation of D/IOC, however, is built into the language and often so lightweight that it completely vanishes. Here's a brief aside for an analogy. In assembly, a subroutine call is a pretty major deal. You have to save your local variables and registers to memory, save your return address somewhere, change the instruction pointer to the subroutine you were calling, arrange for it to somehow jump back into your subroutine when it is finished, put the arguments somewhere where the callee can find them, and so on. IOW, in assembly, subroutine call is a design pattern, and before there were languages like Fortran which had subroutine calls built in, people were building their own subroutine frameworks. Would you say that subroutine calls are uncommon in Python, just because you don't use subroutine frameworks? DTW, for an example of what it looks like to take D to its logical conclusion, take a look at Gilad Brach's Newspeak programming language and his writings on the subject. Constructors considered harmful. Lethal injection. A ban on imports, continued.
Django makes great use of inversion of control. For instance, the database server is selected by the configuration file, then the framework provides appropriate database wrapper instances to database clients. The difference is that Python has first-class types. Data types, including classes, are themselves objects. If you want something to use a particular class, simply name the class. For example, later code can then create a database interface by writing. Instead of the boilerplate factory functions that Java and C++ need, Python does it with 1 or 2 lines of ordinary code. This is the strength of functional versus imperative programming.
It seems that people really don't get what dependency injection and inversion of control mean anymore. The practice of using inversion of control is to have classes or functions that depend on other classes or functions, but instead of creating the instances within the class or function code, it is better to receive them as parameters, so loose coupling can be achieved. That has many benefits as more testability, and to achieve the Liskov substitution principle. You see, by working with interfaces and injections, your code gets more maintainable, since you can change the behavior easily, because you won't have to rewrite a single line of code, maybe a line or two on the deconfiguration of your class to change its behavior, since the classes that implement the interface your class is waiting for can vary independently as long as they follow the interface. One of the best strategies to keep code decoupled and easy to maintain is to follow at least the single responsibility, substitution, and dependency inversion principles. What's a D library good for if you can instantiate an object yourself inside a package and import it to inject it yourself? The chosen answer is right, since Java has no procedural sections, code outside of classes, all that goes into boring configuration XMLs, hence the need of a class to instantiate and inject dependencies on a lazy load fashion so you don't blow away your performance, while in Python you just code the injections in the procedural, code outside classes, sections of your code.
If you want to support the channel, please consider liking and subscribing.